In this video, we will learn about the leontief utility function, how to maximize utility in case of leontief utility function. Okay, so this leontief utility function is also called perfect complementary utility function, or we also say it a fixed proportion utility function. Okay, so it is being given like this: u is equal to minimum of ax and by. Okay, and utility is the minimum of whatever is in the brackets ax and by. Okay, x denotes the units of good x and y denotes the units of good y. Okay, and also let's this is our utility function, and let's say our budget is like this: px, that means price of good x, into units of x, plus price of good y into units of y should be equal to our income. Okay, this is our budget constraint. This is our leontief utility function, what you also call the fixed proportion utility function, subject to this budget constraint. Okay, now how do we maximize the consumer's utility function of this form? Okay, so we can't use the Lagrange method here. Okay, Lagrange multiplier method here. So it's very simple. Okay, so to find the optimal values, or to find the demand function for good x and y, what we do, we just equate whatever is being in the brackets. Okay, so we equate ax with by. Okay, so let's equate ax with by. Okay, so I'm just trying to derive the demand function for good x and y here. Okay, so we can't use the standard Lagrange's method in this case, because we have a main function here. So what we do, first step is equate these two terms here. Oh, let us solve this for y first. Okay, that means our y is equal to a transposing this here, this will become b x. Okay, simple stuff. Now what we need to do, we just need to plug the value of y in our budget constraint. So we have price of x into x plus price of y. The value of y is here a upon b x. Okay, is equal to m. Now let's solve this for x here. So let's take x and x common, so we are left with price of x plus a times price of y upon b is equal to m. Okay, or our optimal value of x will be equal to we have m upon, just transposing this term it will get divided, so we have price of x plus a upon b into price of y. This is the optimal value of good x. Okay, and similarly to get the demand function for good y, solving again this ax is equal to by. So we solve this time uh, for for x this time, so we have x is equal to b upon a y. Okay, again putting this value into our budget constraint, so we have price of x into x. So in place of x we got the value here b upon a y. Okay, uh, plus price of y into y is should be equal to m. Okay, just take y common here, we are left with price of x, or let me write it like this: b times price of x upon a plus price of y. Okay, is it here yes, it is py into y here. So I have taken this common, so we are left with m. Let me check whether I have done some calculations correctly or not. So we have price of x, b upon a y is the value of this, and we have then price of y into y. I have taken y common, so we are left with this very thing here. So it's correct until now. So solving for y, we have m upon transposing this will become price of y plus b upon a price of x. Okay, this is the demand function for good x. Okay, and what does this mean graphically? It simply means this let us say we have units of x on this axis, units of y on this axis. This is our budget constraint. Let us say this is our budget constraint. Okay, and in case of leontief utility function, we have an indifference curve like this. Okay, so this point is our optimal point where the consumer is consuming x star units of good x and y star units of good y. Okay, and why it is called a fixed proportional utility function? Because the consumer is consuming the two goods in a fixed proportion. Let me give you an example here. Let us say we have consumer, he is consuming one apple with one orange. Okay, so he is consuming one apple with one orange, and he gets a utility of, let us say, 10 utilities. Okay, now if he is consuming 1 unit of apple and 2 units of orange, he will still get 10 units of utility. Okay, so this extra orange will not give him extra utility because he is consuming the two goods in a fixed proportion. That means 1 unit of what we call 1 unit of apple with 1 unit of orange. And similarly, if he is consuming 2 units of apple with 1 unit of orange, he will still get 10 units of utility. Why? Because as I assumed that he is consuming one apple with one orange. Okay, any extra apple, if it is not compounded with extra orange, will give him same utility. Okay, so in this case the consumer is consuming his units or goods in a fixed proportion. Okay, and it's also called a perfectly complementary utility function. Okay.